The small tornado looks really cool. Can you make one? Last time I controlled the mist to form a vortex, and it almost turned into a tornado. After thinking about it, I feel that the old plasma fan is more suitable, so I'll take one separately. Actually, this thing doesn't really look like a fan. However, it can indeed produce wind, as explained before. When you use it to blow on an anemometer, you can see the wind speed can reach about 3 meters per second. And it can clear away dry ice mist in an instant. Blowing directly like this is straight up. So I need to think of a way to create several inclined angles. Then by using a cylinder to enclose it and modify its shape, fixing it at an angle, it should be able to make the wind swirl. It's time for some familiar 3D printing again. Just like before, use a corrugated blade to make the high voltage positive electrode. Measure the dimensions of the streamlined aluminum tubing, cut it out to make the abs of the ionic fan, and install it in place. Add 2 screws on the side for easy connection of the wires. Use a large section of acrylic tube to create the wind style. This thing is quite expensive. Evenly distribute around the tube, installing a total of 6. And make a few notches to fit it in properly. After measuring, draw the lines and use a straight milling machine to cut out the notches. And it's easily done. Check it out, it fits very snugly, neither loose nor tight, perfectly in place. No issues at all. Start mass 3D printing, install everything properly, and the total time taken for assembly after printing was 2 days. This is considered fast, using a circular base plate paired with an acrylic tube of the same diameter, but slightly shorter as the base. Carefully apply the glue to ensure it's sealed. In terms of printing accessories, it connects the fan style and the base, making it easy to disassemble for repairs if any issues arise later. The upper layer is used for placing high voltage components, while the lower layer is for holding water and dry ice. The high voltage module used in the can has a 5-volt input and can output up to 30,000 volts, with 6 of them being used. The Palace fan is directly connected to the high voltage module, with the positive and negative poles all set up, making it simple and aesthetically pleasing. The dry ice generates mist, which can reach the top through the middle pipe. The fans are all installed at a 30-degree angle, allowing the wind they blow to swirl around the central mist outlet. Install a cover plate at the bottom to prevent outside air interference. Leave a small round hole for the internal airflow to create an outlet. With the right age, set the positive and negative voltage to about 8 volts and test the effect first. Start by adding hot water, then take out the dry ice sent from the seafood market, and it's fine to put in several pieces. See, it's already fogging up so quickly. Take a look and open it a bit more. The path ahead is too impressive. This effect is wow. A ring light was installed at the top to illuminate the tornado. And not only is the size very suitable, but its brightness can also be freely adjusted. A hole was made on the dry ice layer, and a door was added, making it more convenient to add dry ice and water. Look, the effect hasn't even fully kicked in, and the wind is already swirling up. With the lighting, it looks even more obvious on the left side. Some tornadoes are even finer, just perfect. And the overall performance is very stable, from top to bottom. A small tornado is thus housed indoors, available for viewing at any time. Moreover, since it's a plasma fan, the entire device operates without any noise.